Okay, hello. My name is Yeremia and my student ID is 1030124400013. Okay, so now we're going to the CL04, the number 3 on the assignment. We got this problem. The temperature in the Celsius degree at a point x, y on a metal plate is given by the function. The temperature function T x, y is 400 e power of negative x squared plus y over 2, and then the x should be more than equal to more than equal to 0, and the y is also more than equal to 0. Okay, so the first question is we have to compute the gradient vector, or the gradient vector, and interpret its direction in the context of heat flow. Okay, so and the B1 is we need to find the unit direction vector from point 3, 5 in which the temperature remains constant, or the directions of no change. Okay, so let's just compute the A first. We want to compute the gradient vectors. So the gradient vector formula is this one. So it is the derivation of f to x, so it's fx, and derivation of y, so it's fy. And if we got the fx here, is this one. This is the fx, and then this one is the fy one. Okay, so as we get the fx and fy, we need to combine that as one vector like in here. So I already combine it, so it becomes like this, and we can just see the conclusion based on this vectors. So the first conclusion is the gradient of the vector t points in the direction of maximum increase in temperature. Why is it? Since the exponent is negative, both of them is negative here, the temperature decreases as x or y increase. So no matter what, if the x is increasing or y is increasing, then the exponent is going to negative. The result is going to be negative. Therefore, the direction of gradient t shows the steepest increase, and the heat will flow in that direction from cold to hot in physics, but in mathematically, the gradients point toward the increasing temperature. Okay, so that's it for the A point. So the conclusion is the gradient vector is already we got, and then interpret its direction in the context of heat flow. So the context is heat flow is on the number 3. It is the steepest point. The gradient f is the steepest point, and then if the x and y increase, it will going to get cold. Okay. So we're going to number B, the B point. Find a unit direction vector from point 3.5 in which the temperature remains constant. Okay, so all we have to do is just we need to evaluate the gradient with the 3.5 in here. So we got the gradient first, the gradient of f, and then we just need to input the x and y with 3, 5. So we just input the x as 3 and then y as 5. So this is 3 squared is 9, so plus 5, and then as we count, we got this. So it is minus 1200 e power of minus 7, and then minus 200 e power of minus 7. So we can just get the e out of the vector, so it becomes a constant, and then we get left with this number. Okay, so we need the vector to be perpendicular. Wait, where is it? Okay. To stay in a level curve at the same temperature, it is stable. We must move perpendicular to the gradient. Okay, so we have to move the perpendicular. So we need the vector to be a perpendicular. So we should satisfy the vector v times by the gradient is equal to 0, and the possible gradient t is this one, the minus 1200, 200. Then if we put this into the this one, sorry, not put, it's not times, it is dot product. So it's if the vector v dot product with the gradient t is equals to 0, then the if we how to say it is like if we dot product some vectors with this gradient, it will become 0. So the vector that we found is this one. So if we put this into the equation like this, so this is dot product with the vector we have found, so it is 0. So as this, as I can found, so 200 comma minus 1200 dot product with this one, and it will become blah 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 negative, oh sorry, 0. It will become 0. So it is the correct vector that we're gonna use. So then we're gonna convert this to a unit vector. So the formula for the unit vector is this one. So for the v, we just use the normal vectors, which is this, what we got from this one. Where is it? Where is it? Wait. This one. So it's 200 comma negative 1200. So it's the same. Oh, this should be minus. Sorry. Okay. It should be minus. And then first we count the magnitude first. So it is just 200 times by plus by the 1200. I don't put the minus here because it is not necessary, because it is being quadratic here, so I'll just remove the minus. So we got this. In the end, I got the 100 square root of times square root of 148, or is equal to 148. 1 2 3 1 2 sorry 1 2. Okay, it's like this. We go with this, and we just put that into the equation. So we just put the number. So this is the vector v, or equal to 200, sorry, equals to this. This is equal to v, and then this is equal to the magnitude of v. Okay, as we just compute that, we how to say that, we simplify, we divide both the vector by 100, so this is disappear, and then this also. So we only left with 1 over 148 times by 2 comma 12. Okay, so because we divided both vectors by 100, so the 0 is disappear. But all we wanted to do here is to rationalize this one. So we have to times it by 148, square root of 148 over square root of 148. So yeah, so if we just got a square root of 148 over 148 times by the vector 2 comma minus 12. Okay, so this is our answer. I think that's all for number 3. If there's any question, you can just put it in the comment below, and thank you.